up where we left off yesterday with tangent and cotangent. What do you remember about the period of tangent and cotangent? It's pi, right? And with tangent, you start with a dot on the origin. If it's cotangent, you start with an asymptote on the origin. Tangent is an increasing graph. Cotangent is a decreasing graph. Okay, so that's some of the basics there. Now, example 1, we had written down all this lovely information. So I'm just going to kind of run back through it, what we've already done. Center line was still -1, just like on the sine cosine graphs. That -1 I labeled out to the left. Okay? Then we talked about it. The number out front is a 2, which is a vertical stretch, which means that's going to be, my graphs are going to pull up steeper, not be as flat. The period, remember it's pi over b instead of 1 pi, or instead of 2 pi over b, it's 1 pi over b. So pi over b, pi over 6. So every pi over 6 is a cycle of tangent. And then the shift, still c over b, opposite that sign, so negative pi over 6. And negative pi over 6 says we will be going to the left. Okay. We had done some labeling yesterday, right? Because the period was pi over 6, if you recall, what did I first label? I did pi over 6, right? I did 1 pi over 6. I did 2 pi over 6. Or if you prefer, that's also pi over 3. And then I also, because we're going to shift left, I did negative pi over 6. Remember on tangent, cotangent, I'm going to be asking for you guys to do 2 cycles. So give me a minimum 2 of the curves. And then, with tangent and cotangent, I want you to take each period and break it into just halves. Not fourths, but halves. So I took the pi over 6 here, and I put it in half. Now, a lot of you probably just put the tick mark there, or we talked about a tick mark is fine there. But a half of a 6 is a 12. And notice how it counts. 1/12. This is 2/12, right? 3/12, which I actually put, or pi over 4. This would be 4/12, which is equivalent right there. We also did the negatives. Okay, sound familiar? Recapped? Brains up to speed? Okay, so what graph are we graphing here? This is probably about what I was talking about. We're graphing tangent. So first of all, tangent is an increasing graph. And also, what do we start with on tangent? A dot at the origin. So now, I'm just using pencil for the brief moment. A dot at the origin would mean right here. However, I need to go ahead and talk about my shift at the same time. Okay, good morning. So a dot at the origin. We now take that dot that's at the origin and shift it where? Pi over 6 to the left. So instead of putting the dot actually here, we're going to back it up pi over 6. If I back it up pi over 6, that means I'm physically putting a dot at negative pi over 6. That is my first dot. Now, I would go on and put another, remember, minimum 2 cycles, so I'm going to put at least a second dot, right? So every period, I have a dot. So if I have a dot at negative pi over 6, go one more period, where's my next dot going to be? Before pi over 6. Back at 0, 0 at the origin. Now, okay, so because keep in mind, we shifted left pi over 6 to get for our phase shift. But then what's the period? Pi over 6. So in this particular problem, did the phase shift really do anything for us? No, because the phase shift and the period are the same, we just shifted over to a previous cycle, and it still matches up. Okay, so this is one of those, in all honesty, if you don't do the phase shift, I won't be able to tell as much. Okay? Other than you might not have one, like if I'm looking for 2 cycles left and you didn't actually put one over there, then I might notice. It doesn't hurt. So, okay, so I have one at negative pi over 6 representing the phase shift. And then I'm going to go ahead and I'm actually going to put a dot at 0. That represents 2. You can go another 1 or 2. What would be another pi over 6 over? 1 pi over 6. That's going to set me up for 3 cycles. If I want to go one more, 2 pi over 6. You could keep going and have one at 3 pi over 6, 4 pi over 6, 5 pi over 6. You get the idea, right? Okay, so 1 dot every period. In between those dots, what do you think I need? That's a halfway point, so I'm going to put in asymptotes. So with tangent, we place the dots, and then you put in asymptotes in the middle. So my asymptotes are actually going to fall at negative pi over 12, positive pi over 12, what I have labeled as 3 pi over 12, or pi over 4. Officially, we could keep going, right? There would officially be an asymptote after 2 pi over 6. There would officially be one. I think I am going to go ahead and put one before negative pi over 6. But, you know, at some point you have to choose to stop. Whether you stop with a dot or an asymptote. Okay, tangent is a what kind of graph? Increasing. So we're going to start low between a pair of asymptotes, go up, cross to our 0, and then continue increasing. Because this is a stretch, I'm going to go more vertical through my point as opposed to kind of taking a horizontal zigzag. It's going to be more vertical. Okay? And again, I think our next one will be a flattened, so I'll show you the opposite if you'll give me a chance. Okay? So when I do a vertical, looking kind of like that. That's one cycle. The minimum, you need to put another. And I will say, I'm going to kind of put a star in that first one. That first one is the first one I'll be looking for, because that's what you should put if you did your shift and everything, right? Again, it landed on top of itself, though. I can keep going. I can do a third. I could do a fourth. 2 of those would be the minimum requirement. Okay? Obviously, labeling is important as always. Yes. Yeah. And hopefully you see why I say 2. You know, sine and cosine, they're longer pieces. You know, tangent, cotangent, there's just one of them. And I need to, you know, otherwise I can't really see the labeling if I just say 1. So, okay, questions? Okay, well, when you're ready, let's try number 2. Okay. What about my center line?
3.
The plus 3. And so, while I'm at it, I went ahead and labeled it. It's not amplitude on tangent and cotangent. It is vertically stretch or flatten. Am I vertically stretching this graph or am I vertically flattening this graph? I'm flattening because the number in front is a 1/2, a number less than 1. So I am going to vertically flatten this graph because it is a factor of 1/2. So again, I'll show it when I graph it. That's the easiest way for me to explain it. What else do you notice? Okay, there was a negative, which means this is going to be a reflection. Now, we haven't talked about what a reflection looks like here. What kind of graph is this on this one? Cotangent. So what would a traditional cotangent graph do? It's going to decrease, yes? Reflection is going to take that decreasing graph and flip it upside down. So once you flip that upside down, what's it do? It increases. And it looks just like what? A tangent graph. Yep. So, a reflected cotangent looks like tangent. So we'll do increasing. Okay. I heard period earlier, but I wasn't ready to talk about it yet. What about the period? Pi over 1/2. Okay, so remember, first of all, we start with pi divided by b. So it is pi 1/2 because that's x over 2. Remember, that's like the invisible 1, so I do agree. Pi divided by 1/2, which is pi multiplied by the reciprocal, so pi times 2 over 1, which I also agree is 2 pi. Do we need to talk phase shift? Yes, because there's a C value. So phase shift, C divided by B, opposite the sign. Okay. Pi over 4 divided by 1/2, which means pi over 4 times 2 over 1, which is 2 pi over 4, or preferably pi over 2. Obviously, you may or may not be showing quite all those steps there, but as a teacher, I write them out. Okay. Okay, I've already got my 3 labeled at the left. What's my period? 2 pi. And then on top of that, how many times do I want you to draw this cotangent? Twice. Okay, minimum twice. So if I want you to draw this twice, and one period is 2 pi, what should we really be labeling out to? 4 pi. Does that make sense? Okay, with the pi over 6, it didn't really matter because those are small values. But I don't want you to take up your whole line with 2 pi and then have nowhere to go with a second one. So I'm going to label out to 4 pi at least. If you just want to start counting 1, 2, 3, 4 pi, or if you want to do like we've done in the past where I put 4 pi out and then half it and half it, I don't know. You guys have different. I'm going to leave a little room at the right. Okay, so I put a 4 pi there. In the middle of 4 pi is 2 pi. In the middle of 2 pi is 1 pi. In the middle of 2 and 4 is 3 pi. So can you look at your graph and see it evenly spaced 1, 2, 3, 4 pi? Okay. However, the phase shift is pi over 2. So what else do I need to label in here? The halves. So whether you label them or just put tick marks, we need a pi over 2. In between 1 and 2 is 1 1/2, which improperly is 3 halves, 3 pi over 2. In between 2 and 3 is 2 1/2. 2 1/2 improperly is 5 halves. In between 3 and 4 is 3 1/2. 3 1/2 improperly is 7 halves. After 4, since we're going right, is going to be 4.5. 4.5 improperly is 9/2. Are you catching my reasoning here? I know some of you need that. The other thing to count, this is 1/2, right? Pi is 2/2, 3/2, 4/2, 5/2, 6/2, 7/2, 8/2, 9/2. You have to find a way you understand your fractions. Okay. What am I officially graphing here? Okay, so cotangent is the answer. I'm officially graphing a cotangent curve. Cotangent says we start with what at the origin? An asymptote. So, I would ideally think, I'm just going to, before any phase shift, I'm just putting that 1 just kind of as a reference for the moment. You don't necessarily need to put it in. I'm going to have an asymptote right there. But, what does my phase shift tell me to do? Move that right, pi over 2. So where's my first asymptote going to be? Pi over 2. Now, think carefully. I want an asymptote every period. So I need to go 2 pi from that and make another asymptote. Where is 2 pi later? 5 pi over 2, right? Because, here's my reasoning. This is 1 line past 0, so I need to go 1 line past 2 pi. Does that work for you? And notice I'm not drawing in the originals really with tangent, cotangent. It's just too much to try and do that. If you really wanted to, you could draw in the originals and move each asymptote, right? And where's the next asymptote? Okay, a period of 2 pi. 2 pi later, well, if this was 1 mark past 2 pi, now I need 1 mark past 4 pi. Okay, in the middle of your asymptotes, you need what? The dots. So, asymptote at pi over 2, asymptote at 5 pi over 2, my dot is at 3 pi over 2. Asymptote at 5 pi over 2, asymptote at 9 pi over 2, my dot is at 7 pi over 2. Okay. This first one right there is kind of, I just started because in my brain that's the one that I'm definitely looking for. And then 1 on either side of it. Okay. This is cotangent, so normally we will decrease. But this is a reflected cotangent, so now we're going to increase. Are we stretching or flattening around the center line? We are flattening. So, I'm increasing, and to flatten, what you're going to see me do is have more of a horizontal cut at the center. So, increasing because it's a reflected cotangent. And you can see how I tried to flatten it around the x-axis. Does that explain what a flatten is versus a stretch now? Now, I'll be honest, guys. You have to be intentional here. Because when I grade this, I have to grade, did you stretch or flatten appropriately? Don't make me guess. Did they remember to flatten it out? Or did they not?
You put an arrow in the head.
I mean, be intentional that, okay, like if we compare these two graphs here, do you see a difference? Okay. The first one is more vertical. The second one, and I mean, it works easier because I'll be honest, the wider periods are usually when you need to flatten. So it kind of works anyways, but you can see a difference, I hope. Okay. Let me know if there's questions. Otherwise, I'm ready to go. Got 2 more. It just means to flatten. Officially, so like a flatten of 1/2 versus a flatten of 1/4 versus a flatten of 3/4, it would mean to flatten at different amounts. You know, the smaller the number, the more you flatten it. The closer the number is to 1, the less you flatten it. I don't get that detail. That turns into more of a grading headache than it already is. So, but that's the difference. Just like with a vertical stretch. A vertical stretch of 2 stretches at some. A vertical stretch of like 5 would stretch it a lot more. But again, just acknowledge one or the other and I'm happy. Okay, are you writing down information for number 3? Center of 1. I labeled it so I don't forget later. Are we flattening or stretching? Flattening because the number out front is 3/4. And a reflection because that flattening number had a negative in front of it. So, okay, what kind of graph is this officially? Tangent. What is tangent supposed to do? Increase. Because it's a reflection, what is it going to do instead? It's going to decrease like a cotangent curve. Even though we haven't drawn an actual decreasing cotangent curve, that's my reasoning. What kind of period are we talking about? Okay, pi divided by my b value, which again, notice the 1 there, it is a pi divided by 1/3. So flip it, and it is 3 pi. Am I going to regret not writing that out? Hopefully you're getting it by now. Let's see. Is there a phase shift? Opposite the sign of pi over 2 divided by 1/3. Which is pi over 2 times 3 over 1, which is what? 3 pi over 2. It sounds awkward, but it works in this case, I promise. It's not as awkward as it sounds. And the reason it's not as awkward as it sounds is because look at what our period is. Which, again, that seems awkward, but with sine and cosine, it would be. Tangent, cotangent, it's not. Okay. Labeling. My period is 3 pi. We want to have room for 2 periods, so we want to go at least 6 pi. Now, to go 6 pi, I'm going to use my whole line for 6 pi. I would be careful. I don't feel like you need to label 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. You can, but I don't feel like it's necessary based on what we're doing here. The middle of 6 pi is 3 pi. So right there, granted we haven't talked phase shifts yet, but each of those represents 1 period, right? And we would mark the halfway points. Notice, what is my phase shift? 3 pi over 2. What is 1.5? if 3 halves is 1.5, where is 1.5 here? Halfway in between 0 and 3? So does that, and didn't I just say we would need the halfway point? So I am fine if you just go ahead and say 3 pi over 2. So we labeled 1.5, we labeled 3, we need to label the next guy, and then we have 6. What do I need between 3 and 6? Here's what I would think. In between 3 and 6 is what general number? 4 and 4.5, right? Go that way. It's okay to go that way. We're not going to label 4.5 pi. But 4.5, make it improper. 2 times 4, 8, plus the 1, 9. So this is 9 pi over 2. I did this because I don't want to put all the zillions of extra marks here that's going to make it confusing. That's why I just labeled those marks, because this is going to keep it less confusing, in my opinion. Okay. Officially, we are graphing what graph? Tangent. Tangent starts with what at the origin? A dot. Now, okay, I'm just penciling a little light dot there for the moment. Before I actually start graphing, where do I take that dot? We're going to shift it to 3 pi over 2. So that means instead of actually putting the dot there, I need to put the dot where? 3 pi over 2. And then I need a dot at the next period. So my period is what? Period is 3 pi. So if you go 3 pi later, where is 3 pi later? 9 pi over 2. Okay? Or think about it. I would have been going from 0 to 3 pi. Now I'm going to 3 halves to 9 halves. Okay, I got 2 basic dots. What goes at the midway points? Asymptotes. So I'm going to have an asymptote at 3 pi, 6 pi, and the y-axis. And so this one, it is actually different, isn't it? It didn't land on top of itself, so to speak. Okay, so in my brain, this first one is kind of the one we need. Officially, I'm supposed to be drawing tangent, which is increasing, but I need a reflected tangent, which means decreasing, and then stretched or flattened. Flattened. So, and again, notice it's kind of a bigger, so I'm going to decrease, and then I'm going to flatten. Does that make sense? So that is what my graph looks like. You're probably kind of noticing, on the ones that have the bigger periods, I'm just getting 2 in. On the ones with the smaller periods, you'll see me get, like what I do, 4 on that first one, but minimum 2. Okay, one last one. On this one, knowing what I know, write small if you're going to put your information there at the left, because we're going to be moving left. Or, yeah, put it down below if you want, you know. Center of what? -4. Or redraw your graph down below, I guess, you know. Sorry, I see that. She's too far ahead of me. Okay, center is -4. I'm going to put this -4 at the origin. Put it at the left. I don't know. Get it on there somewhere. What are we doing vertically? This is a vertical stretch because it's a factor of 3. Reflection? Not this time. We actually get to draw an actual cotangent. Period. Pi divided by b. So pi divided by 3. Oh, no fancy stuff here. Phase shift. 2 pi over 3 with a negative out front. Opposite the sign. So -2 pi over 3. And as I mentioned earlier, it's a cotangent curve, right? So cotangent is decreasing. I don't know why I just put cotangent equals. Don't ask. But if you need that visual. Okay. So this is one. I'm not going to label all the way out the 2 pi or anything like crazy like that. My period is what? Pi over 3. So I should probably do some labelings by pi over 3. So I'm going to put a pi over 3. If you want, you could go ahead and put a 2 pi over 3. But what do you notice? We're going to be going left, aren't we? So if we're going left, I would start doing some labeling left, because how far left am I going? -2 pi over 3. So, like if I just made this pi over 3, then equivalent sizing, I keep getting on some of you about this, there's my negative pi over 3. And so if I go left here, another equivalent one is approximately here. There's a -2 pi over 3. And again, that's my personal choice of how to set it up. The labeling is what matters, right? Now, if my period is pi over 3, I just have my thirds in here. I'm going to need some middle marks, so some halfway tick marks. If you want to label them, what would be a half of a third? A sixth. If you don't want to label them, put tick marks in. Okay. Officially, I am drawing cotangent. What does cotangent start with at the origin? Asymptote. So if I just lightly pencil this in just for reference sake, that's what normally would be there. But what am I going to do? I'm going to take this asymptote and take it where? Left 2 pi over 3. So 1, 2. I have an asymptote at -2 pi over 3. How often am I going to put more asymptotes? Once a period. And a period is pi over 3. So where's my next asymptote? A pi over 3 later, which is -pi over 3. Where's my next asymptote? Oh, the origin. So this is another one where that shift didn't really do anything. It landed on itself, didn't it? Okay. And if we want one more asymptote, just because of how I have it labeled, pi over 3. So asymptotes at the thirds. In between the asymptotes are going to be the dots. And, I know, I hit the button, I didn't catch it in time. Okay, start thinking about what you're drawing. Cotangent says we're going to decrease. Are we stretching or flattening? Again, it's a small period, so so don't flatten out as much. It's more vertical. So my first one looks something like that. Looks like the way I set it up, I'm going to be drawing a total of 3. If you just want to draw 2, then just draw 2. If you want to draw 10, then draw 10. I'm expecting to see more along the lines of 2 to 3. I'm not expecting to see like 10, but you know. Okay. I'm going to hand out the tangent cotangent worksheet. It is due tomorrow.